Hi everyone, as you all know, this is Disha Jayar, currently pursuing my BE in Electronics and Communications at Sri Venkateshwara College of Engineering, Vidyanagar, Bangalore. Today my subject is Electronics Principle and Circuits, course code BEC 303. Under that my topic is types of bias. Let's see the types of bias one by one. Emitter feedback bias. Emitter feedback bias is a feedback biasing configuration that uses an emitter resistor to introduce negative feedback into a circuit. The emitter feedback circuit establishes VE via RE, which changes the voltage across RB. It is used to stabilize the Q point. The first attempt is done. Emitter feedback bias as shown in Fig A. An emitter resistor has been added to the circuit, to the base circuit. The basic idea is if IC increases, then VC increases. It causes VB to increase. Here are some equations to analyze the emitter feedback bias. They are IE is equals to VCC minus VBE divided by RE plus RB divided by beta DC. VE is equals to IERE. VB is equals to VE plus 0.7 volt and VC is equals to VCC minus ICRC. This results in a change in IB that opposes the original collector current change. The emitter feedback circuit makes it difficult for the circuit to enter the saturation region. This is because when the temperature goes up, the collector current goes up, but the circuit causes the collector current to go back down. Emitter feedback bias tends to have only modest stability. A combination feedback bias configuration combines both collector feedback and emitter feedback. The another type of bias is collector feedback bias. Collector feedback bias is kept stable with negative feedback, although it is not as stable as voltage divider or emitter. It is also called as self bias and self bias. Another attempt it is also used to stabilize the Q point. The basic idea is a feedback of voltage of the base to neutralize the collector current. The equations to analyze the collector currents are IE is equals to VCC minus VBE divided by RC plus RB by beta DC. VB is equals to zero point 0.7 volts. VC is equals to VCC minus ICRC. With increase of IC, less voltage, one of the resistor RB is connected to the base and the other end to the resistor. The collector base voltage VCB determines the required zero signal base current instead of VCC. Collector feedback bias provides better bias stability than other methods such as base bias or fixed current bias. It works by feeding back a voltage to the base to neutralize any changes in collector current. The another types of the bias is collector emitter feedback bias. Collector emitter feedback bias is also known as collector to base bias or collector feedback bias. The collector feedback and emitter feedback circuits fall short because there is not enough negative feedback to do the job. To improve the stability of Q point, both collector and emitter feedback is combined. Here, the equation to analyze the collector emitter feedback bias is IE is equals to VCC minus VBE whole divided by RC plus RE plus RB by beta DC. VE is equals to IERE. VB is equals to VE plus zero point 0.7. VC is equals to VCC minus ICRC. This method uses a resistor that connects the base and collector. The collector base voltage VCB determines the zero signal base current which forward biases the base emitter junction. This method is dependent on beta and requires two resistors to provide the necessary DC bias for the transistor. The negative feedback negates any change due to the collector current which an opposing change providing by the base bias voltage and thus helps maintain circuit stability. Thank you.